Hello friends, welcome back to my channel. I have received my PCBs and parts from JLCPCB, DigiKey and from other vendors. Unfortunately, BNO055 is still unavailable in the market. My orders are still showing in back order and currently it is due in July. I have only 8 in stock. It means I have to use BNO055 very carefully till I receive more. In this video, I have demonstrated how to assemble the PCBs and run the prototype. The detailed design of the PCB architecture is covered in the previous video. If you have not watched the previous videos, please check the description below. You can also visit to my Patreon site to read the complete paper and download the source code. This video is also sponsored by JLCPCB, who has made the PCBs for me. If you are new to this channel, please consider to give a like and subscribe. That means a lot to me. The production process of JLCPCB is quite impressive. They took only 2 days to print the PCB and DHL Express delivered it in 5 days. If you don't know about JLCPCB, they are China's largest PCB prototype manufacturer. Offers 24 hours quick turn PCB prototype, SMT assembly and reliable small batch PCB production. They charge $2 for 1 to 4 layer PCBs and almost free PCB assemblies. Here is what I have got from JLCPCB. I have ordered 4 different set of prototypes based on my architectures. Architecture 1. Single master controller handling 17 sensors. Here in the board you can see one side has got 9 USBs and other side has 8, along with 2 TCA and 1 Huzzah 32. Both the TCAs has address change option. I only change one of the TCA's address by adding a resistor on the board. Architecture 2. 8 plus 9, which means 2 master controllers. One will handle 8 sensors and other one will handle 9 sensors. This board has 9 USBs, 1 TCA and 1 Huzzah 32. It is similar like architecture 1, comparatively less soldering but still tricky. Architecture 4. Single master controller sensor. In this board, both the Huzzah and BNO will go together. There is no requirement of cabling or USB connectivity. For architecture 1 and 2, I have ordered BNO endpoints, which will be plugged in to the master controller via USB cable. Here you can see in this board there is only one option of BNO055 and USB female. This board has an option to change the BNO's address. So one of the board I will change the address by jumpering the address with the voltage. Comparatively easier to solder. To get the connectivity done, I will make USB cables for architecture 1 and architecture 2. To start with, I will prepare architecture 1 and architecture 4 with 4 sensors each and compare the overall performance. So let's start with architecture 1 first. Before I start soldering, let's look at the materials I need to solder the board. Material lists are already uploaded in my Patreon site as a bill of material. Link is there in the description below. Most of the materials I have ordered from DigiKey. To start with, for soldering, I need a soldering iron, solder wire, soldering flux, a tweezer, soldering stand with a magnifying glass for better visibility, multipurpose tapes, a multimeter. For SMT component for architecture 1, which is single master controller, I need USB female type A, 0 ohm resistor, JST plug, pull-up switch, 16 pin and 12 pin female connectors, 2 TCA9548A and 1 Huzzah 32 feather. For BNO endpoint board soldering, I need 12 pin female connector to raise the BNO height from the board, USB female type A, 0 ohm resistor. For the USB connector cable, I need 2 USB type A male connector, RJ11 modular telephone extension cable, heatsink tube and heat gun. To solder the board, at first I'll solder the difficult one, which is 0 ohm resistor soldering. These are so tiny, very difficult to see. This is the first time I will solder such a tiny component. Past few days I have seen so many YouTube videos on that to learn SMT or SMD soldering, which really helped. Some of the links are there in the description below. To solder such a small component on the board, at first apply solder flux to the board and put some solder at one side of the board after heating it up. Using the tweezer, I place the resistor onto the board and then hit the side where the solder was applied. Once it's stuck to the board, apply solder to the other side of the component. Most difficult part is done. For the first time, I have done a good job. Now I will solder the USB female type A. It is recommended to solder all the females first and then solder other components. To safeguard my Huzzah 32 and TCA, I will mount all these components to a female connector instead of soldering them directly to the board. USB type A female connector soldering process is same like the 0 ohm resistor soldering process. At first, I have applied some solder flux and then one pin of the connector I have soldered and then the opposite pin. Finally, I have soldered other two pins along with the side pins. Once the USB females are soldered onto the board, I have soldered one 16-pin female for Huzzah 32 and 5 12-pins female for Huzzah 32 and 2 TCAs. Here is the final outcome of the soldering. My first solder was 3 months back. Now looking at the outcome, honestly, I am feeling proud of my job. Now let's test the circuit. To do that, I have created a small Arduino code to scan the I2C bus. Arduino code is very simple. I run a loop from 1 to 127 addresses to read the I2C component. Here in the output you can see my TCAs are successfully detected with the address 70 and 71, which is expected. Now let's test the power of all the USBs. To do that, I use a multimeter. The orientation of the USBs are ground, SDA, SCL and VCC. Here you can see all the USBs are powered by 3.4 volt. Now let's move on to BNO endpoint soldering. The BNO board soldering is simple. It has BNO component and USB type A female. I will solder two of the board to test the master controller. One for BNO address 028 and other one for BNO address 29. The reason is one BNO will be connected to the Huzzah via TCA and other one will be directly connected to Huzzah. Let's start soldering the difficult one, which is adding a 0 ohm resistor to the board to change the BNO address. This can also be done by just jumpering two leads using solder bridge. But for practice, I will use a resistor to change the address. Here is the outcome after soldering the resistor. Now it's time to solder USB type A female socket to the board, which is same like soldering the USBs in the master controller. BNOs are very precious nowadays. To safeguard and avoid the soldering BNOs onto the board, I will use two female sockets, one 4-pin and other one 6 pins. BNOs will be plugged in to those female pins so that I can remove the BNOs in future as and when I need. Now it's time to prepare a cable to connect the BNO with master controller. To do that, I need two USB type A male plug, a wire stripper, heatsink tubes, a heat gun and of course RJ11 cable. After stripping the cables, here you can see all the 4 cores which are perfectly colored for our I2C standard specification. If I remember the orientation of the USBs in the master controller and BNO boards, then the order of the USB male plug will be exactly opposite. It means VCC, SCL, SDA and ground. I have stripped off the cable and soldered all the cores into the male plug. Here is the final cable look like. After hooking up the cable one side at the BNO and other side of the master controller, let me first check the voltage. Here you can see the voltage of the BNO endpoint is 3.4 volt, which is same as the master controller. Now it's time to test. So far my master controller recognized 2 TCAs. Now I have connected one BNO in the I2C bus of the Huzzah, which was address 29 and other one with TCA. To test the whole circuit, I have further modified the I2C scanner code. I have added a function called TCA select, which takes 3 arguments: active TCA address, passive TCA address and TCA port. In the loop function, I have identified the TCA. I have added 2 for loops to loop through the TCA port and find the active BNO on that. That's it. On testing, I could see 2 TCAs and the BNO running on Huzzah I2C bus has been recognized. Now, if I add a BNO to one of the TCA port, then I can see the BNO is correctly picked up by my code. Now, if I change the port to another TCA, output reflects the BNO identification. This shows my circuit is perfectly working. Before I moved on to more details on the same, let me check the battery level. Now the question is, how can I monitor it so that we can raise an alarm if it goes beyond some voltage level? To do that, I have declared two variables at the beginning called max analog val and max battery voltage and defaulted to 4095 and 4.2. Now in the loop function, I have added 3 lines of the code to print the battery level at every iteration. That's it. On running the same code, I can see my current battery voltage is also being printed onto the serial port. Currently this battery is being charged via USB cable. I need to check the battery level by its own, and that can only be done on transmitting the data in Unreal. Now it's time to move on to the other circuit. The concept of architecture 1, 17 channels, and architecture 2 or 3, 8 plus 9 or 4 into 3 plus 5 channel is same. Only difference is number of BNO connected to the master controller. I will solder and test those as well later. Before that, let's look at the architecture 4, which is Huzzah and BNO combination. This is 17 individual sensors without being connected via cable. This architecture is expensive but easier to handle, and it is less clumsy. Here is the board I have got from JLCPCB, in which I need to solder 4 female sockets, 12 pins and 16 pins for Huzzah 32 and 6 pins and 4 pins for BNO. The materials requirement for soldering is as same as like the previous board. I have encountered a small problem in this board. I have connected Huzzah's reset pin to BNO's reset pin and Huzzah's interrupt pin to BNO's INT pin, but have not considered the connection in the Arduino code. So to break the connection from the board, I have taken out Huzzah's side reset and INT pins from the female socket before soldering. This is how the circuit looks like after soldering. Now let's place the Huzzah and BNO onto it to test. The code is very simple. At first, I have scanned the I2C device and then reading BNO's Euler data. Finally, I have transmitted to Unreal. To send the data to Unreal, I have changed the JSON structure a little bit. This time, instead of sending array, I am sending JSON object with name and orientation detail. In the serial monitor, I could see BNO has successfully identified and data started coming out of BNO. Now let's work in the Unreal. In the Unreal UDP controller human blueprint, for the time being, I have bypassed the for each loop and connected the UDP event to the third person anim BP object and connected the JSON value to the JSON object function. Now on playing, I could see the upper arm is moving. It means code-wise everything is working as expected. There are some unexpected behavior or data corruption of the sensor data causes some glitches in the 3D model. Those are when roll angle reaches around 135 degree, your direction changes by 180 degree. When pitch reaches around 90, roll direction changes by 180 degree. Both these two glitches are logical, but the problem in the 3D model's bone direction, which I need to fix, but I will fix that in the next episode. So far, all the PCBs are working as expected. My concerns are, for 17 channel or architecture 1, the should become little heavy and clumsy due to so many connected cables. Secondly, the battery life with all the sensors is only 2 hours. For Huzzah and BNO combination, there is a small defect in the board, which is related to the reset and interrupt pin. Secondly, the width of the board is little bigger. If I need to bring another sensor in the mix like GPS to improve the data quality, then architecture 1 will be very difficult to manage. Therefore, I have decided to go with architecture 4, which is BNO Huzzah combination, and work it on to improve the size and data quality along with the perfection. In the next video, I will demonstrate the new design and the output with the orientation fix. That's all from this video. A big thank you to JLCPCB for sponsoring. Lot of your recommendations related to the sensor are really valid, which will definitely help me to reduce the cost. I will definitely test those sensors in future. Some of the things might be easily or efficient way to achieve that I might not be aware of. If you could point out those tips and tricks or better way of doing it will be a great help. So please comment and help me out. On that note, I am finishing this video here. I hope you like the progress and the strategy of the development. Please stay tuned for such interesting topic and the solution. Till then, stay safe and take care. Thank you for watching.